So thank you, Clay, and very happy to be here. It's always a highlight to speak to this distinguished community from all over the world, connecting all space. I think is a very good slogan, and that's exactly what we are doing. And I'm very happy to contribute partially to these connections that can be made. I've put a few slides together just to give you some updates of what happens in Europe, just to put it a bit in context of the various activities. And just to, if this works, yeah. ESA, I don't think I need to introduce ESA, European Space Agency. You know it very well, just a few facts and figures. I think the one figure that sticks out, which is remarkable here, is that of the budget which we are implementing, which is about 7 billion, this is about 60% of all the public funding in Europe in space. The other 40% are being national space agencies or the European Commission or EUMETSAT or some other entities that are spending space. So in other words, the majority of space activities is funded through ESA programs. And as you know, we have ministerial conferences on average every 3 years where we organize our activities, where we make proposals to the member states, to the ministers, and then ministers are subscribing to our programs, and that's the way how our budget is composed. About 2/3 of this budget does come from our member states, and about 1/4 from the European Union through agreements which we have with the European Commission on Copernicus, Galileo, and some of the other activities. And the other portion is bilateral agreements, third-party agreements with our countries. Looking back, what have been some of the key milestones? You see some pictures here. Of course, the astronauts are dominating the messages. They are extremely good ambassadors. You see on the left-hand side, Matthias Maurer, on the right-hand side, Samantha Cristoforetti. They have been in the space station last year. Samantha was following Matthias. Matthias was following Thomas Pesquet. So with these 3 astronauts, we had a year and a half uninterrupted, with probably 2 days interruption, but almost 1.5 years of uninterrupted presence on the space station, which is quite unique, but very important for us to really conduct the research, the activities on the space station. But you also see some other pictures here. One, of course, is the Orion module. The European Service Module, as you know, is powering the Orion capsule, is providing not only the energy for the propulsion, but also for climate, also for the habitat inside, temperature, energy. And it's really the module that makes sure that the astronauts can live in the capsule when they travel to the moon and back. And this certainly is something where Europe is extremely proud of, that we are an essential part of the mission to the moon with the United States and with other partners. And this is something that I think is also a sign of trust of our American friends that they have chosen us for this very critical task which we are fulfilling here. In the middle you see Gaia. Gaia is one of our science missions. Actually, it had the data release number 3, as we call it, last year, which is one of the largest data releases. Some people call it the Google of the Milky Way, really a complete mapping of the Milky Way with billions of objects, and it is really containing very detailed information. Actually, Gaia today is the source of data for most of the scientific publications in space science, so an extremely powerful data source we have. Of course, James Webb Space Telescope, I don't need to explain, but just to remind everyone that Europe is an important partner, of course, under the leadership of NASA, of the James Webb Space Telescope. Out of 4 instruments, 1.5 are provided by Europe, plus the launch. Everyone remembers the launch on Christmas Day 2021, which was on top of Ariane 5, and which was so precise that the life duration of the James Webb Space Telescope has been doubled because of a very precise insertion into orbit. Then you see also the maiden launch of Vega C, which we had in July last year. Unfortunately, later on last year, we had a failure of the Vega launcher, and this is something that we are working on right now to get back safely into orbit with our launchers. ESA Budget, just to give you a quick overview, this is our division of different activities, so here by domain. The largest ESA budget is attributed to Earth observation, about 1.7, bit more than 1.7 billion, but you also see larger portions of our budget are in navigation, on human space flight, microgravity exploration, on the science, space science, on the launcher part has several components, Ariane, Vega, Guyane Space Center, but also future space transportation, technology, scale-up, telecoms, and so on. So this is a bit the breakdown of our budget. But as you see here, and if you would compare this budget with NASA, for example, of course, in NASA, you have a much more focus on exploration, while in Europe, the focus is really on the applications. The applications, that means telecom, navigation, Earth observation, is about half of our budget. Booming global use of space. No need to explain the topics, but just to highlight some of the domains where everyone is experiencing a very fast growth of the space economy. Of course, also in Europe, we are participating and contributing to this boom. These are some of the domains that are listed here: climate, in-orbit servicing, space connectivity, human space transportation. The last one, and this was what you mentioned, Clay, in terms of announcement. Just last Thursday, we announced a report from our group. We call it the High-Level Advisory Group, which are non-space people, very eminent people, but not from the space sector, who have been meeting for about half a year, and to reflect on whether or not Europe should have its own spacecraft to fly its own astronauts on a European spacecraft with a European capsule to LEO or to the moon as a further destination. And this is a big question. As you know, today we are not having our capability, but this is the question I'm going to raise now to politicians, to our decision makers, based also on the input which was released last week. It's really worth reading because it gives a very good motivation from a non-space perspective. What are the main arguments why one should engage in this domain? Of course, some other nations are already deeply engaged, but Europe not yet, and this is exactly the question which we would like to address. New space economy, you know very well these figures. They are comparisons of some of these facts on the new space economy. On the left-hand side, you see the launches of the number of satellites that have been launched per year, and the numbers, I think, are explaining themselves what this means between 2021 and 2031, a very sharp increase, as we all witness and we all know. But also the global private space investments, which you see on the right-hand side. You see the $13 billion or euros, which have been coming in terms of private money, and which really increased or almost doubled compared to the year before. Last year, by the way, there was a slight decrease. It's around 10 billion last year. We just got the figures in, while in Europe, this figure kept increasing, almost doubling, but at a lower level. And also on the global public investments, you see here the figures of 93 and 113. Again, very strong investments in space across the board, both from the public sector as well as the private sector. Milestones. These are some of the milestones we are having coming up on the side of ESA. One of the big milestones just a couple of days away is the launch of JUICE. JUICE is a very large satellite with 10 scientific instruments flying to Jupiter and looking at or monitoring the 3 icy moons, Callisto, Ganymede, and Europa, and looking really what happens under these ice covers. As you know, there's a very thick ice layer on these icy moons, several tens of kilometers thick. Underneath, there's a big ocean. We expect it about 100 kilometers or up to 100 kilometers deep. And underneath, there's a core, either ice or rocks. And this is exactly what we would like to study. What is in these oceans? Are these oceans habitable? In other words, is there a possibility that there is life in these oceans? And just imagine there would be life there, or we are not looking for life, we're not searching for life, but for the habitability, as it is called, whether the conditions are right for some kind of life to be there. But just imagine there is life there, or we would discover that there might be a likelihood for life. Of course, the next question would be, would this life have the organs or the life there, would they have a DNA? Would they have the same DNA as we have? And of course, the answer either yes or no, I think is answering a lot of questions and probably opening a lot of other new questions, but the meaning would be quite impactful. And this is something quite exciting. Then you see Euclid. Euclid is another space science mission looking at dark matter and dark energy. And this is something very abstract, of course, something that is not well understood. We know that about 96% of our matter is dark matter. That means only 4% of all the objects we are touching is the ones that we see, that we can grasp, we can understand. The other 96% we don't. And this is exactly what this mission will look into, to better understand some of these secrets of dark matter, dark energy. This is a very exciting mission to be launched, or the launch date, the nominal launch date is 2nd of July this year. We have Andy Morgensen, our next astronauts coming for the space station at the end of August. Before that, you see that the new astronauts, which have been selected last year, are now starting their training on the 3rd of April at European Astronaut Center. And looking really creating a new generation of new astronauts. We do plan another space summit. You see on the bottom right in Seville at the beginning of November, which is the second space summit. The very first one was in Toulouse last year. A very important event which brings together the member states of the European Union and the European Space Agency to really address major, bigger questions which we have in Europe. What we plan to address at the Space Summit in November, at least this is the current planning, is two main domains. One is the use of space for climate and climate monitoring to help the economies and the governments to decarbonize the economy or become carbon neutral, especially with the deadline 2050, which most European countries have agreed to. And the second point is really human exploration, exactly what I mentioned before, this report which was released last week, to see where Europe wants to go and what decisions Europe wants to make in this domain. So very exciting topics which we have on the agenda. And of course, Ariane 6, inaugural flight. We're working quite a lot and quite intensely to get towards the maiden flight. If you ask me today when this will be, I cannot give you the answer, because we still have a few main milestones in front of us, technical milestones, and once we pass these technical milestones, which will be around June, then we will be in a better position to give a maiden flight date, but also a ramp-up scenario for Ariane 6. Here, just some pictures to highlight some of the elements I mentioned before, JUICE and Euclid. JUICE is now in Kourou, getting ready for launch, and on the right-hand side, Euclid, which is being prepared for launch in the July timeframe. Also, we had quite an important launch in December last year, MTG, Meteosat third generation, a completely new mission, which is much more precise, giving much more frequent observations of our disk. Is a geostationary satellite used for meteorology, following, of course, the long series of meteorological satellites since 1978, and really continuing the very good cooperation with EUMETSAT, but also the very good work we're doing here in the global context together with our Japanese, Chinese, American friends on meteorological observations from geostationary satellites where we produce one set of data for the community. EarthCare is another example which we do together with Japan. It's a joint ESA-JAXA mission. Also getting ready for launch sometimes early next year, and Copernicus Sentinel-1C, which is also being prepared for the launch in the Earth observation context. Space exploration. This is the bigger picture of our engagement on space exploration, from Leo to the Moon to Mars. We have quite an interesting set of activities and programs which we propose. On the ISS, of course, a continuation of our operations, of our activity on the space station with astronauts as we have them today. I mentioned Andy Morgensen, who will be launching later this year. But the new generation of ESA astronauts that are being trained right now would also in the future go to the space station. Then we prepare for the moon together with the US on the Artemis program, but on one side to prepare or to provide the modules for the gateway itself, but also we have at the last ministerial put proposals on the agenda for moon activities, in particular Argonaut, which is a large logistic lander, and Moonlight. Moonlight is an interesting project which looks at the moon, will build up a navigation and telecommunication system around and on the moon, which of course you need if you build up an infrastructure and really have a longer infrastructure planned for the moon. And on Mars, we have two main activities. One is Mars Sample Return, together with NASA, and ExoMars, of course, very well known, with a bit of a history which was a bit difficult to manage, but we have managed now to get ExoMars back again on track for as a European mission, with some contributions from our friends from NASA, in order to really have ExoMars starting or launching in 2028, meaning that we will have the rover on ExoMars, and we will be able to drill into the surface of Mars about 2 meters to really search for traces of previous life on Mars. I mentioned the astronauts. This is the 17 candidates which we selected. It was a long process. We had 23,500 applications, an enormous amount of applications. So it took us a year and a half to really go through the whole selection process. So these are the lucky winners which remained at the very end. And they are now, 5 of them are now the career astronauts starting training. The other ones, reserve astronauts, which are looking for other opportunities, which are developing these days as we speak. Gateway. What you see here is a picture of Orion docked on the gateway and with very strong European contributions. IAF and Esprit will be the major elements of the European contribution, together, of course, with other space agencies. Again, NASA leading this program. Very exciting, as you all know, and we really look forward to our parts in exploring the moon, not only going there, but really this time staying there and making good use of it. I mentioned Moonlight. This is a graph showing the navigation telecommunication system. If you have rovers there, if you have astronauts there, they need to navigate, they need to communicate. And this is really a service where we expect also some commercial applications to come out. So industry will engage. We have a lunar pathfinder which will be launching earlier, but Moonlight itself will be built up as an operational system, again, together with our Japanese and American partners to really make sure that we have a coherent, standardized system for operations on and around the moon. I mentioned Argonaut. This is the way it looks like. This is the large logistic lander. It's quite a large spacecraft, about 8 tons of weight, and it will be capable of transporting 1.5 tons to the moon surface. This can be some equipment, this can be instruments, this can be various activities that we are bringing there. The plan is to launch this Argonaut by the end of this decade, and then have several of these missions. So not only a one-off mission, but really having this repeated several times in order to really build up a moon economy as it is planned, and this will be one of the major contributions coming from Europe. ExoMars, as I mentioned, this is the ExoMars rover. You see here in front the drill, which is the one that actually goes into the surface, about 2 meters. There will be an analysis of the samples on the Mars, on the rover itself, in order to search for traces of life, to look for traces of life which come out of this drill. Quite an exciting mission. The science will be quite unique. Nobody else will attempt to drill into the surface, and this, I think, is something that is really very exciting when it is coming to Mars. Another important project is secure connectivity. Secure connectivity, of course, you know very well. Europe has now launched the legal framework and has launched a program at European Union level together with ESA. On the ESA side, at the last ministerial, we have obtained 640 million as our contribution to about 1.4 billion of contributions from the European Union. Just these days, a couple of days ago, the first request went out to industry to make their first proposals. There are several rounds of proposals, negotiations until a final offer will be evaluated, and we expect this to kick off and start work early next year. Navigation, this is a very interesting project. We call it LEO PNT. So navigation, as you know, normally is flying in mid-altitudes, mid-Earth orbits. But in this case, we have proposed a program to our member states at the last ministerial to have a component that is going to low Earth orbit in order to, for two reasons. First of all, to increase the accuracy of the signal, but also have a much stronger signal, and the stronger signal would allow deeper penetration and therefore wider usage of the navigation system, but also it would further increase the accuracy of the navigation signal and therefore being used for, as you see here indicated, for autonomous driving or similar applications where, of course, you need very high precision of the navigation signal. Already today, especially with the HIS signal, Galileo is providing the most accurate navigation positioning system worldwide. Another interesting project is this one here, which is Clear Space. It is a spacecraft that literally grabs an object in orbit. There are millions of objects in space, as you know, space debris, some big ones, many small ones. But this is one that is that will grab an upper stage of a Vega launcher and literally take it out of an orbit where it is in conflict with other objects in space. This will be launched in about 2 years and will be quite an exciting mission. What we also want to achieve, and this is something quite important, is to achieve a zero debris policy of ESA, which we are promoting right now, meaning that if you launch a satellite into orbit, you commit yourself to bring it out again at the end of its life. And if you can't, these kind of devices can help you to remove it. Of course, you need a regulatory framework in place, maybe insurances in place that an insurance would then help you, insure you against a spacecraft not being able to be taken out of orbit, and therefore you pay for a service. So this is certainly an economy that is quite interesting that might be developing in the future. Solaris is something that has made some headlines recently. I have to say that this is a concept and we are doing a feasibility study. This is not yet a confirmed project, just to manage expectations. But if it works and if the feasibility study is positive, this would be tremendous in terms of changing our way how we can collect energy, become independent, but also in terms of carbon neutrality, this would be a huge step forward. The idea is that we have a gigawatt power plant in space based on photovoltaics, where the photovoltaic energy is transmitted down to Earth, is collected. Of course, this is quite large dimensions that we need there for a 2 gigawatt power plant, and therefore provide energy, I would say, from at any point or any point on Earth. You could eventually also use the same concept on the moon or on other places. But this concept, if it works, if the feasibility is confirming, I think this would be a huge step forward in order to create some energy independence, but also provide a base load, because you can get this energy 24 hours a day if you position your spacecraft in the right place. What we do here, maybe just back to Solaris, what we do here is really assessing the technology on one side, but also some other elements that are related to regulation, regulatory aspects, and some other aspects that are done. We will work on this. We have allocated several tens of millions of euros in the current ministerial package. And if the answers are positive, that means that this can become a project. We will then propose it in 2025 as a new project, a new element at the next ministerial. Accelerators and inspirators. This is something a bit different from how we usually run an ESA project. Normally we prepare a program proposal together with our member states. We negotiate the various aspects. We come with a proposal on the table, and member states then subscribe. And as you know, we have a system in ESA where member states can put a lot of money into a program or no money, depending on how attractive it is for them. So therefore, we have to be really sure that we have an attractive proposal, otherwise it would not be funded. But in the And then we implement this program once the project or the program is funded, and then we run it with industry to develop a spacecraft, a rocket, whatever we do. On these accelerators, it's a bit different, because there we have a different concept where we believe, and you see the themes that are highlighted here: space for green future, rapid and resilient crisis response, and protection of European space assets. These are big themes where, of course, we know that there's a need to tackle them. I take green future as an example. This has all to do with reaching carbon neutrality by mid of this century and decarbonizing our economy. This has to do with energy transition from one source of energy into more renewable energies, transport, industry, agriculture, forestry. There are many aspects that are involved here. So what we want to do here is help our countries who have actually huge programs for the decarbonization of the economy or reaching carbon neutrality, to really help them with our space means to achieve these goals. There are funds at European Union level, at European Commission, at national level, some private organizations which are really helping to decarbonize the economy. And in some cases, space can contribute, in some cases a little, in some cases a bit more. But what we want to do is building partnerships with these entities who are having a task to decarbonize the economy, as an example for the Green Future Accelerator. That means we are one partner, maybe a small partner in a bigger partnership, in a bigger consortium, and everyone is implementing their activities according to their rules and their priorities, but space will help to make it happen and really make a change in terms of the various elements that need to be done. So therefore, this is not a classical ESA program where we take care of the whole decarbonization chain, but we work with other partners. Of course, some of the funding will come through ESA, through our usual ministerial conferences, but this is much more building up a major partnership based on building blocks from many contributing partners. This is something that we have launched. It's now ongoing. We have now a group of people working in-house. This is something where we are now building up partnerships with the various entities that are interested in joining. On the right-hand side, you see the inspirators. I mentioned already human and robotic exploration. This is certainly something that will keep us quite busy this year to build up this discussion, the momentum for the human exploration part of on the European side. And on the other side, you see here Icy Moon Sample Return. That relates a bit to the JUICE mission, where eventually, once we discover that JUICE has a habitability for possible life around these icy moons, whether or not we should have a sample return mission, which of course would be a major interesting exercise. A last word on ESA Transformation. All this is, of course, what I showed here are programs, projects which we're implementing, but also I'm looking a bit into our internal machinery of ESA. That means all the processes, all the procedures which we have. In other words, or in simple words, we would like to make sure that we are cutting red tape where we can, of course, always being accountable on one side towards our taxpayers, on the other side ensuring quality of our outputs, but certainly we can simplify processes, speeding up processes with different or simplified rules, making sure that we really adjust and adapt to the challenges which are out there, because in the new space economy, things go very fast, very dynamic, and of course, as an organization, we need to make sure that we're ready for all these challenges. On the other side also, we are getting a lot of new funding. Mentioned the ministerial, where we got 17% more. That means quite a plus the inflation on top. So more money, more projects, but also, of course, the workforce therefore needs to work differently to manage these projects in a different way. And one last graph to show a bit the acceleration roadmap. So what are the next steps coming up on our side? So you see some of it that already happened. We had the high-level advisory group that in 2021. We had a space summit in 22, which I mentioned. We had the ministerial in November last year, extremely successful. And now we have the space summit coming up at the end of November this year, the second space summit. And then, of course, we go on our side towards the ministerial in 2025. And with this, I'd like to thank you for your attention.